All right, the chromium has been investigated as coating for steel cans. The thickness of the chromium film is determined by dissolving a sample of can in acid and oxidating the resulting chromium 3 plus to this ion with the peroxide sulfate ion, which is this. Okay, let's take a look of this equation over here. And after removal of unreacted this ion, the peroxydisulfide ion, an excess of ferrous ammonium sulfate, which is this ion, is added, reacting with this ion, produced from the first reaction. Okay, is reacting with this one. Okay, the unreact uh, iron ions from the excess ferrous ammonium sulfate is titrated with a separate of this ion over here. Again, let's take a look over here. This ion is the same of this ion, which means when we finish this, when we finish this reaction, we remove this one, and then we will have left this, and we will have a little bit excess of this ion. So what we do is add this to react with the remaining one. And after we do this, we find out that, oh, I add too much. That after all of this was reacted, I still have some of this remaining in the complex. So I add more of this, which is come from here. This is additional. I put a little bit more of this over here. And finally, I can make all of this disappear. 好，用中文讲一次，就是我进行一次反应的话，我让这个地方进行一次反应，让这个 S2O8这个离子去进行这个反应，然后我会产生很多这个铬酸根吧，应该是铬酸根。那Cr2O7我就不管它的名字。那我产生这个东西之后呢，我最后会使用这个有点复杂的这个 ion 去跟它进行反应。那最后这个东西发现说，哎，氧化还原进行反应的时候，我想把这边剩下消除，结果呢，我这边消除完了，结果这边太多了，所以呢，我又自己还加了一些 K2Cr2 O7 来进行把这些东西太多的东西反应掉。Okay, so let's take a look over here. What does this mean? FeQ plus. Let's see. Let's take a basic look over here. This is water, so it does not have any electrical charge. And this is sulfate ions, so the charge is minus 2. And this is ammonium ion, this charge is plus 1. So let's see about here. The whole thing of here is 0 charge. So let's take a look over here. This is minus 4 by total over here, and this is plus 2. And this is all plus 0. So the the iron should be plus 2. So basically, we have the concept that the iron came from here. Okay? Okay, so the first question is, write a balanced chemical equation for the two reaction. Okay, 那这是我们要进行氧化还原. So we are doing some oxidation reduction of this. So let me teach you how to do this effectively. So basically, we have two kinds of method to solve the oxidation and reduction problem. One is just balance it. The second one is to write the Huff equation, which we write the reduction and rewrite the oxidation. And then we plus it together. But when we have unbalanced equation from the problem set, we just simply balance it. Okay, so the first step is, you see, we just have to do the major role of the equation. So for example, the first one, the major role is chromium and sulfur atoms. So the first thing to do is let the major role be the same in both sides of the equation. 所以第一步是我们先让两边的这个主要去反应的这些原子，先让它变得一样多。Okay, so at first we see there are 2 chromium over here and 1 chromium over here. So first, let's multiply this into 2 first. Okay, secondarily, we see there are 2 sulfur atoms over here and 1 sulfur atoms over here. So again, let's times it into 2. Okay, secondly, let's calculate the total charge, whether it is minus or positive, it's negative or positive. Let's calculate the total charge of the major role of this oxidation reduction reaction. 那第二步的话，我们就是先计算一下哪一个是我们先计算一下主要去参与反应的这个原子，它的总共的离子总共的电荷数是多少 ？Okay, so for here, change my color. Okay, so for here we can easily see this is +6. Okay, and so over here, the total chromium oxide ion. I don't know how to read it, but sorry. It is 2 minus. Okay, so the oxygen is always -2. So this is what it contributes. It will equals to -2. So we can know that the 2 chromium over here is total +12. Okay, now I think you can get a more clear thoughts of how to do in this. Okay, later. Next step is let's take a look about the sulfur ions. Okay, so the total charge is -2, and the charge contributed by the oxygen atoms is -8. So we can see over here the total of this sulfur ion is 6. But be careful over here, because we have already multiplied by 2 times. So this will total be 6 times 2, which is 12. Okay, similarly over here, the total is 2 minus. So the charge contributed by the oxygen is -16. So we know the 2 sulfur over here contributes +14. Okay, I think this is easy enough. All right, so later on, let's calculate how many changes occurs inside of this reaction. So let's see the row over here. Okay, the sulfur turns from 14 plus into 12 plus, so it's a reduction. Yes, it's a reduction. -2 over here. And the chromium comes from +6 into +12. So totally +6. So the oxidation and reductions should be balanced inside of this calculations. So one is +6 and another is -2. So we know that this should be times by 3. Okay, simple enough. So in this place, all of the row of sulfur should be times by 3. So this 2 times 3 will become 6. Okay, so later on, let's duplicate our recent work over here. 3 sulfur dose. Okay, now the charge is still not balanced, so we have to use the hydrogen. We have to use the hydrogen ions to balance the equation. So let's see over here. The total charge in the left-hand side of the equation is 3 times minus 2 and plus 2 times positive 3, which is 0. So in the right-hand side should be 0 as well. So, okay, in this part is 2 minus and plus is 6 times minus 2 is totally negative 14. So we know that the right-hand side should be 0 charges as well. So we have to use the hydrogen ions to balance it. So we know that the answer over here is 14 hydrogen ions. Okay, it's not over yet. After we balance the charge, we have to balance the atoms. Because why? We add several of hydrogens over here, so we cannot balance it very easily. Why? Because you add too much over here. We do not have any hydrogen atoms over here, but you add hydrogens here, so we have to use water H2O to balance the whole equation. So let's see over here. We have 14 hydrogens over here, so we have to add 7 water over here. So basically, this is the finish of this equation. But if you're not very clear what I'm talking about, I will explain to you again in this question. Okay, I'll balance this again. So if you don't have any problem, you can move on to the part B, but the equation should be balanced as well. So let's do this again. Okay, so basically, okay, let's see. Iron, it's all 1 mole, so we don't have to time anything. Chromium, okay, 1 is 2 chromium, 1 is 1 chromium in the both side. Okay, in the left-hand side, there's 2 chromium, and in the right-hand side, there's 1 chromium over here. So we have to time the right-hand side chromium into 2 first in order to calculate this. Okay, so basically, okay, the iron part is easy because it is just a simple ion. So we can basically just write +1 over here. Okay, let's do this again. Chromium is total a -2 charge. So the contribution from the oxygen ions is -14. So the total contribution from the chromium is +12. Okay, so +12 over here. Okay, later on, it turns to chromium 3+, but we already multiplied by 2, so it should be +6. So it is easy now. Reduction by 6. So it's easy to find out +1 minus 6. So the +1 part should be times by 6. 6. All right, okay, let's duplicate this again. Okay. So let's see over here. We have to balance the charge again. So here, let's take a look without the hydrogen atoms. First one, 6 times +2 plus -2 is 10. And over here, 6 times 3 positive plus 3 is 21. So this part is positive. This part is +10, and this part is +21. We have 11 difference. So we know that the hydrogen over here should be what? Did I do anything wrong? Did I do anything wrong? Oh, sorry. I did a mistake. I have a mistake over here. This is 2. So this should be 2 plus 3, and this is +24. Okay, correctly again. The difference between the right-hand side and the left-hand side should be 14. So we have to add up 14 hydrogen ions over here. And then in order to balance the hydrogen atoms, we should make up 7 7 moles of water over here. Okay, that is the answer of part A.